Welcome back, everyone. Yay, someone said yay, thank you. Hopefully, all of your mornings and afternoons were as interesting as mine. I met some incredible attendees. I still haven't hit my goal of everyone. Help me out, please. Come, please. I want to meet y'all. And I saw some incredible talks. I was just talking with Wade just now. I am so overwhelmed with the quality of the presentations that have come through. Every year, I have a little bit of a panic attack. Is the presentation going to be late? Will the formatting work? Will the presentations meet the moment? Will our speakers be able to deliver the content that our audience knows, loves, and deserves out of this event? And I am speechless with just how good the content is this year. So quickly, give me a round of applause again for all of our speakers and the hard work they've done. Incredible, incredible stuff. This morning we saw Neha. When Neha said yes to coming to speak at our conference, I was surprised. I was like, wow, we did something. This is great. But when our next speaker told me that he was willing to come back and speak for a second year at our conference, I was truly overjoyed. You know what I'm talking about if you were at FinTech DevCon last year. His presentation was incredible, but it was also hilarious. If you are paying attention to the privacy space at all, you know him and you know his company. If you're not, shame on you. But please help me in welcoming to the stage our next speaker, co-founder and CEO of Skyflow, Mr. Anshu Sharma.
The first thing you're supposed to do is bring the clicker with you on stage. All right. Well, the model never unlearns and I never learn. So thank you so much for coming. We try to make this session as much fun as possible for me, and you guys suffer. We'll see. So I think one of the things that surprised me in the last year, and it hasn't surprised you, then you guys are genius, was the launch of the GPT, GPT 3.5, GPT-4, LLMs. And I think those of us who've experienced it a little bit and have had our minds blown, are probably still vastly underestimating it. And I was at Oracle in 2005 and 6 when EC2, S3 were just coming out. They were in beta. How many of you remember that S3 and EC2 were in beta for like years? Like literally for years. And how many of us ran production software on those beta instances? I think when these things are happening, it doesn't really hit you as hard. And if it does, it's a little bit overwhelming. And you go thrash between, oh my God, this is going to change everything. Nobody's going to have a job. All the way to, this is overhyped. How can you have a French LLM? Anybody here read about the French LLM startup? Apparently, some very smart VCs gave somebody like a few $100 million because they claim they're going to organically grow an LLM in the southern region of France. And it's going to be like Burgundy, so it can't really be called Champagne unless it's from that region. So you are seeing crazy things like that happen. I'm sure some VCs are here, maybe some even who've invested in those companies. My goal today is to take that extreme hype or extreme fear away. I'm not going to try and tell you how it's going to steal your baby's jobs and you might as well just quit working. I'm an optimist. I do think it'll change the world in very positive ways. And yes, there'll be some idiot out there who'll build a bot that's going to fill up all the forms in the world with like monkey or something, and we're going to be like, oh my God, like we have a virus built by LLMs. I'm surprised actually there's no virus yet out built using an LLM. I think that just like has to happen. So what are we going to do today? We're just going to talk about what's happening. I'll try and share my learnings. As I said, I didn't know anything about this space, so I'm not an expert, till about Jan or Feb of this year, when I was talking to the co-founder of Salesforce, actually, and they were beginning to hear things. And he said to me, if we have to build these models, how do we make sure that one customer's data doesn't touch another customer's data? Who's going to trust whom? And then I heard from somebody who works at a Cupertino-based company that you can't name legally. And he said that we have a voice assistant. Some of you might have used it. But we're beginning to think about using LLMs in the next generation for certain use cases, which I can't talk about. But where we get stuck again and again is if the model learns things, how does it unlearn? And I'll talk about that a little bit, because turns out, just like human beings, I don't know if you've seen those movies or read those books where human beings just can't forget anything, and eventually they go mad. So the machine learning models have basically the same problem that we humans have, that you can't forget things on command. You can forget things, but if I tell Wade to forget something, he can't. And that's a challenge that all these models have. So how are we going to build these amazing new experiences without having the most basic fundamental functionality that every file storage system, database system, operating system has always had, which is the ability to delete data? If you thought you were coming to the keynote about the model never learns, this is not that room. That session is being led by our friend. So obviously, this guy never learns. And of course, the models we are building never unlearn. A little bit about myself. I started Skyflow about 4.5 years ago, mostly because this idea just wouldn't go away. I worked for 8 years at Salesforce, 7 years before that at Oracle, and sometimes some new problem comes across. So when 2006, I saw virtualization and cloud computing, and you just can't get it out of your head. So I tried building a cloud at Oracle, completely failed, as you can tell. How many people have production applications on OCI today? Okay, so I failed and decided that these guys are not serious about building it, and joined Salesforce. I've been invested in a bunch of companies. Somehow that enhances my credibility. But there's some fun companies in here. Shout out to Algolia, a YC company, Razorpay, YC. I think it's YC demo day today or yesterday. So what are we going to talk about? Well, this new thing, how will this change fintech? How will it change the life of your customers? And what can we learn from the previous two revolutions in mobile and cloud? And for some of you who've removed it from your resumes, blockchain. No, I'm not going to talk about blockchain this year. I don't see any blockchain startups today out there in the sessions, or even a session. Is there any session on blockchain this year? 2 sessions? All right, 1 more year. Well, I bet my career on blockchain going to 0, so I have to check. I know a lot of people are technical here, but those of you who are not familiar with how LLMs work, let me give you just some basic talking points so the rest of the presentation is actually easier to understand. So foundation models are not from Asimov movies. Foundation models are basically, as they sound, they're the basic models that some very large companies have built. The most familiar one that you probably know about is GPT-4. And so what they've done essentially is taken all the knowledge in the world that's freely available, we'll find that out too, and built a model, and that agent is able to answer a lot of questions. And then a lot of other companies, ranging from Google to Amazon and Facebook, have learned from that and said, hey, I want to build my foundation model too. Foundation models, a lot of people think of these things as some kind of a new cloud service, some kind of new database, but actually that's a very wrong way of thinking about it. The best way to think about a foundation model is probably closest you can think of is Wikipedia. It's common shared knowledge that a model is able to compute on, as in answer English language queries. So if all you remember about foundation models is this, imagine a 16-year-old who's read every Wikipedia page and has extremely good English and can write as if they went to McKinsey. That's basically what a foundation model is. Fine-tuning is basically saying, hey, this foundation model learned everything. I am trying to, let's say, so the foundation model, for example, will know something about viruses, because that's an entry in Wikipedia. But let's say I was trying to build a model that could answer questions about COVID-19. There is some additional knowledge that has to be gained, and that you can store in the form of a vector database, retrieval search, etc. Whatever you want to call those additional technologies, that's sort of your databasey part of your system. And you add that to your foundation model so that when you ask a question that's not fully covered by Wikipedia, they can rely on this additional information to fine-tune the answer. So instead of giving you a generic answer about, say, COVID-19, they can also, let's say, look up the image of a virus. That would be a retrieval search that you would do based on the information you gathered. So combined with these two things, you can start building more and more interesting applications. The third thing people can do is, instead of building your own foundation model, fine-tuning it, you can do what's called prompt engineering. It's really just like telling the 16-year-old, hey, don't give me the answer in a paragraph, give it to me in bullet points, and make it look like a chart. That's basically what prompt engineering is. You're engineering the response by giving some additional information. So how are these LLMs being used today? There's lots of startups that have already begun building some amazing things. Some of them are in stealth, so I can't tell you what they're doing. But there are 3 here that are either customers of ours or companies I've invested in. As an investor, that's a favor I do to people. I put their logos. But they're actually very interesting companies. Hippocratic AI is the first company that's building a foundation model for actually clinical data. So they're actually gathering a lot of patient records and such, and then building a model such that it can act as maybe a qualified nurse. So think of all the questions that you have to ask a doctor's office that in reality a doctor never answers. There's some junior person there that answers the question, or if you have the time and patience, like some of us nerds do, you search the NIH database and find the answer yourself. That information can actually be learned, composed, and questions can be answered by Hippocratic. But as these companies are building these things and ingesting all this healthcare data, they have the same problem, which is, how do I make sure that actually I'm building the model that's actually true to what happens in real life, but obviously I'm not legally allowed to ingest anybody's healthcare data in its raw format. There are other 2 stealth companies here. Peer AI, for example, is building a pharma specialist. A lot of the work today that's done by doctors and pharma companies is basically, those FDA documents that you get, 13 pages? Somebody got paid $5 million to make sure that's accurately written so that when something goes wrong, you can't really sue them. A lot of this work is requires a lot of diligence, knowledge of detail, and doesn't really require innovation. And that's where LLMs shine. If there is work that you think is repetitive in nature, that's where you want to apply LLMs. So what does that mean for fintechs? Here's some examples. The easiest way I think about this is whatever a database application do really well today is actually not a good use case for LLMs. Anything that today you handle through emails and PDF is where LLM shines. So imagine you're building a financial advisor that's helping you plan for retirement. There's a calculator stuff that you have to do. If you have $4.3 million and you take out 6% a year, then blah, 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 this happens. But what if you want to ask a question, hey, what if I moved from America to Mexico? What if I went back to grad school after I retired for 2 years and my spend was going to go up for $40,000? Well, the traditional database systems can't handle these exceptions and corner cases, which turns out as actually 90% of what we really want to know. Nobody here really wants to see what 6% of 4 million looks like and pay somebody money. You can do that in a calculator. But those things are very easy for a LLM to handle because as dumb as they are, they're good at details, they're good at understanding these things, and they can answer the question, especially if you can train them on real data. So imagine you are a company like Vanguard or Fidelity. How many people here have tried to transfer their 401k from one company to another and had email after email and phone call after phone call? The reality is these people have basic combinatorial problem. If there's 100 companies you can take money from and move it to 100, it becomes 100 times 100 combinations that they have to know the answers to, which is 10,000, those of you not doing the math. So your customer support guy, whose only job is to help you figure out what form do I need to give to E-Trade to move my 401k to Fidelity, has to know 10,000 individual answers, and the answers at the detail level of you must right-click on this thing on this page and then send an email, et cetera, et cetera. These laborious tasks, even listening about that makes you feel sleepy, right? These laborious tasks are hard to actually document. They're hard to automate, but exceptionally easy tasks for an LLM to do. Same thing true for customer support. Think about a transaction assistant helping you buy a home. What are the questions you have about buying a home? They're never like, hey, can I afford a $5 million home or a $50 million home? We all know that. The questions you have are like, hey, how close is the nearest school? What kind of crime is happening in the neighborhood? These general knowledge questions with some specificity is what LLMs can be trained on and then fine-tuned on. So that's where we are. What do we learn from the previous generation, these transformations, is most of us will get it wrong. As much news as all of you are reading here, and as much as CEOs of the biggest companies are coming on CNBC and talking about they're all in on LLMs, I guarantee you 90% of us and 99% of them will get it wrong. Give you an example. In the mobile era, I had dozens of conversations with CIOs of largest retailers who were 100% convinced that nobody ever wants to buy something on a mobile phone. There was this idea of an omni-channel experience, and you would basically maybe browse the catalog, but because buying is so complex, it had to be done on a desktop. And by the way, that's what people did. If you ever bought anything 10 years ago on eBay or Amazon, the UI was so terrible and their apps were so bad, they could prove with data that nobody's buying anything on my mobile app and everybody's coming to the browser. Everybody now knows what the real answer was. They were just doing it wrong. By the way, this is also where just build what your customers are asking is wrong 100%. Because if you ask those people, hey, do you want to buy more things on the mobile phone or the browser? They would again and again tell you browser, and they would be wrong. In the cloud era, same thing happened. The biggest companies said, look, cloud. It's for those throwaway applications. It's those dev and test systems. Some of them got wiser and said, yes, there's something real happening here, but we're going to build our own cloud. Everybody who has $1 billion plus in CIO spend always wants to build everything themselves, especially if it can get them on the cover of a New York Times article. But the reality is, it doesn't always go your way. JP Morgan Chase, finally, our friends are here, 2017, got religion and said, maybe public cloud is serious business, it's time to move. Think about this. 2006, 7, people like me were quitting their jobs at companies like Oracle, moving to Salesforce. I spent 7 years there, left, became an investor, grew old, had a beard, and finally, the customers I started talking to in 2007 were beginning to think that maybe cloud thing is real. That's what most incumbents are going to do. And the reality is, history doesn't repeat, but it rhymes. Earlier this year, we had, not picking on my friends at JP Morgan Chase, I love you guys, but it's just the easiest example I could find. All financial services companies had the same posture, so we would love to work with JP Morgan. But hey, they're very nice people. They have a great payment stack. But the reality is, this stuff is hard. It's not that Larry Feinsmith doesn't understand the value of LLMs. It's that the logical answer today is you cannot deploy OpenAI into your environment. Because who here wants their S1 prospectus leaked if you're filing for an IPO? Who's going to take the liability on that? Who's going to make sure that the investment banker for company A that's acquiring and company B, whose stock could move if that happens, don't talk to each other? There are literally laws involved that could involve people going to jails, which make people who are extremely smart say things like this, that you cannot deploy these things until all problems are solved. Some of these companies are also saying now we build our own foundation models. So just to give you an idea, the 3 things I told you about foundation models, fine-tuning, and prompt engineering, in dollar terms, the first one is $100 million, the second one is $10 million, and the third one is like 10 cents an API call. So when people talk about, hey, I want to build my own foundation model, what they're saying is, I will have that expensive thing on the menu because I can afford it. And also, that's what will get you front page news in Wall Street Journal, which 10 years later, I'll come here and talk about it and make fun of you. But the funny thing is, the people who helped us move to the cloud era sometimes are also the people who are confusing things. To pick on our friends at Google and Microsoft, they are actually going around telling companies that you cannot just use OpenAI's foundation model API. Why? Because if you call their API, you're sending data that may include sensitive data. It may have things like phone numbers, social security numbers, which is actually true. But that problem part is true, but the solution part is sort of self-serving, in that just like Dell and HP told large financial services companies 10 years ago, cloud is good, but you should build your own. These guys are saying, LLMs are awesome, but because I'm not OpenAI, you should actually build your own LLM using one of the foundation models and pay me the top of the ticket, $100 million a year. So what's the solution? What they are saying is actually accurate. So it's not a case where any of these people are doing illogical things. It's a classic problem with innovator's dilemma, that when you do logical things, 10 years later, you end up as Nokia, right? Or BlackBerry. Anybody see that BlackBerry movie? It's actually pretty awesome. It's available on Netflix now. I love watching all those movies. It makes me feel good. as a founder. So if we forget the fact that you have $100 million to spend, and I'm willing to take it, if you take that aside, what exactly is the problem with LLMs, and what are we really trying to solve? And is there a way to have your cake and eat it too? Is there a way for us to do this rollout safely? The other thing I want to mention is we're laughing at them, but all of us, unless you started your company in the last 18 months, your tech stack looks like Wells Fargo's tech stack, and JP Morgan's tech stack, and PayPal's tech stack. All of us started in the database era, and the cloud era, and the mobile era. None of us here have some giant LLM business. So it's actually a great leveler, which means we could actually, for the first time, lose the race to the big guys if they do the right things. So we have to move faster, or we all lose. It's not the case that we have some kind of a unique proprietary edge. In fact, LLM is one of those areas where the bigger companies have an edge. Because if you're trying to fine-tune something, trying to build a foundation model, obviously, a Wells Fargo or JP Morgan has 1,000 times more data than a fintech with like 500,000 users. So by definition, they have a competitive advantage. So what's going to help you is moving faster and solving your problems. Let me give you a little bit of an overview of the AI architectures. So now that we've established that people need to build these things, is there sort of like an agreement coming? Well, not everybody agrees on the details of it, but I do see a convergence of AI architectures happening. This is from Andreessen Horowitz. It's a little bit of an eye chart, but to simplify things for you, essentially what they're saying is you're going to have a bunch of data. You're going to build a model, run a model, tune a model, and then you need to actually host it, run it, manage it, and then you need to secure it. Each of these things then has an investment associated with it, and hopefully they make money. Mark Benioff, who's slightly better at marketing, as you can tell, has a simpler way of explaining the same thing. He calls it the GPT trust layer, Einstein. But essentially, all they're saying is, you have your data, you want to build something, you need to actually make sure that before the data goes into your models, both during the time of building or enhancing the model, or at the time of using it, you need a trust layer in the middle. And this trust layer is going to have a few capabilities. One of them is to make sure that the data that's going in doesn't have any sensitive information that shouldn't go in. So things like masking the data, dynamically encrypting it, tokenizing it. There's a bunch of techniques you can use. And then you need to make sure when the response comes back, it somehow actually magically still has that information. And this is the hard part, by the way. So imagine if we took everybody's income here statement for last 7 years, including your social security numbers and phone numbers, and we're trying to build a model to basically answer basic questions like, how poor are the founders? And you need to feed all the information in there accurately. However, when you ask the question, it has to be able to tie the information for one founder at a time. If I want to ask a question about whether Wade or Anshu has been able to buy a home, and what are the next steps to buying another bike that will help you bike more, it can't be an answer about somebody else. It has to be an answer about Wade. So this is the dilemma that everybody has. You can throw away the data, but then the model is dumb. If you retain the data, the information goes in. This is Google's architecture. As you notice, everybody basically has the same thing. VPC, VPC. So what VPCs give you is model isolation. It's like saying the model for this entire room is different than the model for another group of people 1,000 miles away from here. What it doesn't give you is fine-grained privacy controls. And that's the missing part. And this is why I was calling those companies Dell and HP, because yes, there is some benefit, arguable. The people at OpenAI will tell you that they actually never, ever use your query data to actually train the models. The data does hit their servers, but they don't actually retain it, I think 30-day policy and such. But I can understand if you're in a regulated industry, you could be paranoid. But isolation of your model is kind of like living in a single-tenant world. Getting a single-tenant version of Salesforce or Snowflake may be better than getting a multi-tenant for some people, but fundamentally doesn't solve the problem of who can see what, when, where. Because within that tenant, there's going to be thousands of users, maybe millions of users, data that's actually going to be learned, not stored. And then you have to answer questions. So what we need is more than just model isolation. We need to be able to actually, very, very fine-grained manner, decide who can see what, where. Another VC firm, Foundation Capital, they put this diagram together. But what they're beginning to say is, if you want to do something like this, you need to actually have a security layer, observability layer. You need to basically build what Mark called the trust layer. And you need to pick a model. Turns out, actually, in the just last 6 months, there has been a whole number of new models released. Just today, Facebook announced their next version of their model in open source that basically is performing way better than the other models. There's an arms race going on right now in the foundation model space. That's why NVIDIA made $12 billion in the last quarter selling chips. But in addition to picking your model, whether it's open source or not, you need to have a bunch of other questions that need to address. As I said earlier, unlike databases, the models don't have a delete button. There is no row, there is no column where you can say, hey, this row, this column number, Jared's income and social security number will not be shared with Wade. How do you actually enforce all of that, given that the model basically turns everything into the ether vectors? So that's a problem statement. You have to inject this into the architecture before it goes into the data wall. So I'll give you some couple of examples here. So companies like Hippocratic AI and Peer, what they're doing is they're adopting the data privacy vault architecture, essentially filtering the data of sensitive information in a manner that keeps the relationships in place without actually revealing the information. I know it sounds magical. It's kind of like LLMs. But it works based on polymorphic encryption, tokenization, and these technologies. One good thing we learned from blockchain was you can actually do computations on data without ever decrypting it. The reason, after everything, $1 trillion equivalent of tokens and coins are sitting on the blockchain and you and I can't have it, is because we can move money from one person to another person by doing something called a homomorphic computation calculation. That's what enables people to transfer 3.6 Bitcoin from one account to another. You don't have to decrypt either my information or the recipient's information. That calculation can happen homomorphically. So while blockchain is on its own journey, you can actually take the technology or the concepts behind it. Some people call that zero-knowledge proof, zero-knowledge computations, and apply them in a novel way such that you can actually start building your models without having that raw information in there. This is the new privacy architecture. Essentially, in the old world, maybe because we had those row-level access control rules in there. We could do RBAC. We could do policy-based enforcement. We could do those things. You could potentially go out there and buy a security product for each of those things, right? There are lots of companies out there that just sell database security, API security. People even sell products for the arrows between these boxes. So I always joke, each box and each arrow is a $100 billion market, and securing that is a $10 billion market. And if you don't trust me, just look up Palo Alto Networks price. But the reality is, when you do that, you essentially end up with a dozen tools. Imagine I have that architecture. Let's imagine I bought everything. I bought Cloudflare, I bought Palo Alto Networks, I bought Zscaler, I bought API security, I bought everything. And now I want to basically set up a very simple policy saying, any customer support person that's not level 2 should not be able to see international customers' data. Or I want to set up a policy that simply says, no customer support person should be able to see 100 people's data in a day. Where do you set that up? Do you go into Cloudflare to set that up, into Zscaler, into some other tool? Policies have no meaning if they can't be enforced. And so that's the fundamental brokenness of our security architecture today. We have point solutions, and then we have security for point solutions. And occasionally, there'll be a company that comes out and says, I'm going to integrate all of that. But that's still just integrating things that are fundamentally broken. What that leads to is two problems. One is you can't define your policy. You can't say, in my large language model, forget large language models. Even in a database, you can't say, hey, I built a wealth management application. It has 3 simple rules. The user cannot see the data unless they are within United States. So if you're traveling, maybe they're not allowed to see because it's a security measure. One of the companies that we're working right now was telling me they have 200 customers. Let me refine that. One of the best customers we have today has 200 users. This company actually has sort of like a multi-family office wealth management system. So each of their customers is actually a billionaire. And even to buy their software, they actually oftentimes have to get interviewed by like ex-CIA officers and such. Now, not all systems in the world are like that, but essentially that's what we all want. We want the protection that a billionaire would get if they were worried about losing money. I was joking to him, I was like, me losing $40,000 is more pain than a billionaire losing $400 million. But the reality is you need very, very fine-grained controls in place, even in the database world, just to make sure that your application data doesn't leak from one user to another, doesn't accidentally get shown. And then there are other things that people have to take care of, such as GDPR, such as all the data protection laws in different countries. All of those things today are getting harder and harder because we've taken a piecemeal approach to actually thinking about privacy and security. And now we throw LLMs in the mix. Well, if you're loading all that data to LLMs, and you already don't have controls in place even for your Snowflake instance or Databricks instance, you're definitely not going to be able to put those controls in place for LLMs. So the alternative approach, the cleaner architecture, is to use something like a data privacy vault. You can pick any. You don't have to pick mine. What it essentially does is the idea is very simple. And this is a paper, by the way. We didn't pay them. I met the author. They're actually ex-Microsoft people. Essentially, the idea is very simple. Isolate all sensitive data separately. It's like what we do in our personal lives. If you have expensive jewelry, watches, you go buy a vault. If you have very expensive jewelry and watches, you go deposit them in a bank locker. You isolate that information, you isolate that thing that you most want to protect, and you put very, very fine-grained controls everywhere, instead of taking the opposite approach of trying to control all things at all times. Now, you have to do both in some ways. You can't leave your front door open just because you have a vault at home. But because you have a vault, you have an additional layer of security that completely isolates certain type of information. We've basically built a commercial version of that. You can come talk to us. But let me give you some examples of what people are doing with this architecture. Sorry. We are seeing customers do 3 things in the LLM space. One of them is when you're building a foundation model. So as I said, some people are willing to spend hundreds of millions of dollars. When those companies are building their foundation models, today they have 2 problems, in addition to many others, such as procuring NVIDIA chips. One of them is copyright issue, which is if you build your foundation model and has anything in it that's copyrighted, it becomes impossible for you to later on actually remove it. This is where, by the way, search indexes are different than LLMs. If Google indexes some information on your website, let's say you have a proprietary formula for making Coca-Cola, and Google indexes it, you can go to Google, Google can go find that row and column and delete it. But if GPT-4 somehow was able to index the Coca-Cola formula and learn it, you wouldn't be able to unteach it. You can actually play some tricks. You can say, hey, LLM, forget the old formula and remember the new formula is just salt and sugar. And it may answer that going forward. But then someone else can come in and say, give me all formulas for Coca-Cola and it would have that information too. So you can't quite delete the information after the fact. So one of the problems is to get rid of copyright information. Unfortunately, I can't help with that. But that's where actually a lot of money is getting made. Some of you here who have data that's clean and proprietary, there is a lot of money to be made right now if you can find the people who need it. The second part is just sensitive information, not just copyrighted data, which is I am ingesting, let's say I'm a large legal firm. I want to basically cut down the bills for my lawyers. Actually, it's not true. I want to continue billing the client at the same rate, but I want to pay my legal assistants even less money. A whole range of questions and answers can actually be automated away. But to do that, that machine has to go read every lease out there with all the information in there. And when you're building a model, it's not like building a database. You can't just say, hey, drop column C. There is no column C in your PDF that the thing is ingesting. So what you do is you put basically some kind of a filter or a firewall in the middle. We call it a privacy vault. You could call it privacy firewall. Essentially what it does is it takes Wade's phone number and turns it into 650-994-7738, not his real phone number. And then when the machine is learning other things about him, it has a consistent information. So it actually can build the life profile of Wade and how many bikes he's bought and how many loans he had to take to buy those bikes, and have that model end-to-end and predict when he's going to buy the next bike without actually knowing his name, knowing his phone number, knowing his social security number. And yet, when the salesperson or the bank person asks the question, when is Wade likely to buy his Nike bike, it will again turn Wade into X47, turn his phone number into the fake phone number, go into the machine learning model. Machine learning model doesn't know about Wade, but knows about X47, prepares a cogent reply, long form. The response comes back. It gets converted on the way back by the firewall into real information, and that's what gets sent back to the agent. So you can, weirdly enough, give all the data in the world to an LLM, including during building the model, tuning the model, training the model, running inferences, and not have it exposed to either the OpenAI's multi-tenant service or to the isolated model. So essentially what you're doing is you're putting controls in place on the system before the data goes in or the data comes out. So if you don't want the model to learn something, don't teach model that thing. And that's basically what the new architecture is all about. And we would like to talk to you more about it. So if you're around, come by our booth. If there are questions around LLMs, up to the third question I can answer. We have some other team members who can give you more details. Let me leave you with a couple of examples of things that I think are happening, but maybe we are not realizing. I think we will have a real doctor LLM within the next 3 to 5 years. Most likely, none of us here would be legally allowed to use one. You would have to go to Mexico to simply chat with a Dr. GPT. The good news is while you're there, you can pick up your medicines for cheap too. But the way things are going, you will have that. I grew up in India in a lot of smaller cities. We used to have this thing called a doctor, and then people would say, "You're going to a doctor?" And then, "Yes." And they would say, "Like an MBBS doctor?" Which meant like that person is a real doctor, has a degree, as opposed to someone who's a pharmacist, or even better, a guy who's to work at a pharmacy for a few years. They're all doctors in India, by the way. And the reality is, if you're a poor person in most parts of the world today, or you're without insurance in America, your doctor is already someone who doesn't have a medical degree. Your doctor already is Google. You already are taking terrible advice from random people on the internet. You're searching Reddit forums to figure out what to do with your COVID. If you don't believe it, we all saw that happen in the last 3 years. People are fundamentally not getting the information they need. I think within the next few years, we will have a medical LLM system that actually outperforms all the non-MBBS doctors, and actually for a lot of conditions, the MBBS doctors. A lot of things in our lives that are chronic, for example, even a real doctor can't treat them well. So if you have, in my case, I injured my foot some time ago. For years, you go to the doctor, they're like, "Does it hurt?" Yeah, sometimes. Does it hurt a lot? No. Well, do you want an MRI? No. Well, I can't do anything for you. You should go see a podiatrist, which, by the way, is a fake doctor. Or go see a chiropractor. But the reason is there is not enough money in it for them, just like there's not enough money in our system for somebody that's pre-diabetic. Treating a pre-diabetic and preventing diabetes just doesn't make any money. All of those conditions are better treated by something that actually has state. So if you think about what is a chronic condition, it's a long-running state machine. Well, what's good at running long-running state machine and can combine it with the long tail of information? Well, it's basically a database and an LLM. So I think we'll see that. I think we will not see people losing their jobs. All that will happen is you will now be able to get care for things that are today commercially inaccessible to you. And there will be large parts of the world where people have no medical access, where they will be able to take photos of their injuries and other things and actually get a written prescription. The other area which I'm excited about is drug discovery. It took me a very long time to understand this one, but one of our customers has been building these protein folding models, which I don't understand what they are. But finally, he explained to me in simple terms. Everybody here heard about the coronavirus and COVID? Basically, it has this corona-like thing. You basically have to find a medicine that can somehow go get stuck in that shape, and so that you can prevent the molecule from replicating and doing other things. Anybody here heard about Wegovy, the magical weight loss drug? That's basically goes into a GLP receptor. It's a semaglutide. It's a weight loss drug that's very popular now. All the actors and actresses are suddenly losing 15 pounds by exercising more. But think about the GLP-1 receptor. It took 20, 30 years for people to do all kinds of research, and we found one such medication. That medication is already one of the fastest growing medications in the world, and it may actually cut down the rate of diabetes in this country by 50% or more, because all indications are it has very little side effects and is near perfect. Now imagine you invented semaglutide, but you found out that it does have one weird side effect, that in addition to going and sticking to your GLP receptor, it somehow also goes into your heart, and like on the off chance, sometimes it affects your valve. Well, 10, 20 years ago, what you would have to do is basically throw away that medicine and start from scratch and find another random molecule that can do that. Today, using these computers and using LLM-like technologies, you can actually figure out another molecule that looks like this one, but doesn't have this weird NOH side thing hanging from it, and run a simulation on toxicity, and run a simulation on efficacy. And you can do all of that in a few weeks. So all of that innovation is basically going to happen if, and only if, we actually get these LLMs to work. So with that, I hope that we all double down and build magical applications using LLM. And do come party with us tonight. Happy to take questions. Otherwise, thank you so much.